You are welcome to my YouTube channel. Our topic today is the binomial theorem. We are going to start by defining some basic tools that we will be needing in the process. Factorial. For any natural number n factorial denoted by n exclamation is the product of the first n natural numbers. Okay, so what is 0 factorial? 0 factorial is defined to be 1. That is, for a natural number n factorial is equal to n times n minus 1 times n minus 2 times ... up down to 1 in descending order, while 0 factorial is 1 and 1 factorial is also 1. So basically, this is what factorial stands for. What about combination or combinatorial symbol? By definition, for non-negative integers r and n combination r is equal to n factorial all over n minus r factorial. And after proper simplification, you're going to have what is there, which is n in bracket n minus 1, n minus 2 down to n minus r plus 1. And the numerator all over r times r minus 1, r minus 2 down to 1 in the denominator. Okay, the combinatorial symbol n combination r can also be denoted by nr, cnr, ncr, or cnr. These are different ways they can be written. Now, binomial expansion. To start, we calculate directly the first 5 natural number powers of a plus b raised to power n, arranging the terms in decreasing powers of a. So a plus 1 raised to power 1 is actually a plus b raised to power 1 is a plus b. A plus b raised to power 2 is a squared plus 2ab plus b squared. A plus b raised to power 3 is a squared plus 3a squared b plus 3ab squared plus b squared, and so on. So if you observe, you will see that while the value of a is descending, the value of b is increasing. So that is how binomial expansion works. Let's look at some examples. If you use the binomial formula to expand 1 minus 2x raised to power 4. Solution. We write 1 minus 2x as 1 plus, then in bracket minus 2x. So that my a in this case will be 1, while my b will be minus 2x. So when you do the substitution properly, you are going to have 1 minus 8x plus 24x squared minus 32x cubed plus 14x4. So that is how the simplification is done, and the expansion is done using binomial expansion. It makes the expansion easier to handle. Another example here is says expand x plus 5y raised to power 5. Hence, evaluate 1.05 raised to power 5 correct to 3 decimal places. These are different ways questions can be asked in binomial theorems. Now in this case, our left hand side, you write x plus 5y raised to power 5, and if you do your expansion properly, you are going to have x squared plus 25 x raised to power 4y plus 250 x cubed y squared plus 1250 x squared y cubed plus 3125 xy4 plus 3125 y raised to power 5. So this is what you're going to have, and but that is not all. So with x equal to 1 and y equal to 0.1, we are going to obtain 1.05. What it means is I've been able to separate 1.05 into x and y, or if you like, into a and b. So when you substitute, anywhere I see x, I replace it with 1. Anywhere I see y, I replace it with 0.1. That is in this, from this particular spot. Anywhere I see x now, I will put 1 and y 0.1. And when you do the simplification properly, it will be approximated into 1.276. And I think that is the final answer. Now, the general term of the binomial expansion. Each term of the binomial expansion looks like NCR A power n minus r b minus r. If you have been observing properly, where the value of r ranges from 0 to r equal to n, because the expression NCRA raised to power n minus 1b raised to power r is typical of each and every term in the expansion. We call it the general term of the expansion, and it represents the r plus 1 term of the expansion for r going from 0 to 1 to n. Let's look at this example. In the binomial expansion of 2 minus 2 over x raised to power a, written in terms of descending powers of x, we should find the fourth term. This is a typical question. How do we handle this using binomial, the general term of the binomial expansion? Solution. So the fourth term is derived from the general term, where a is 2, b is minus 3 over x, n is equal to 8, while r plus 1 is 4, so r is 3. Now, the fourth term, you look at the left hand side now, you substitute all those values, a, r, n, and so on. Once you do that properly, and a and b, you're going to have what is on the right hand side, which is 8 factorial all over 8 minus 3 factorial 3 factorial times 2 raised to the power 5 times minus 3 over x raised to the power 3. And when you do the simplification properly, you're going to get that the fourth term of the binomial expansion is going to be minus 48,384 all over s squared, s cubed. Let's look at another example. You should find the term in s squared in the expansion of x minus 1 over 2x all raised to the power 12. To find the term that have s squared in the expansion. Here, the general term will be 12 combination r x raised to the power 12 minus r times minus 1 over 2x raised to the power r. Okay, we don't know what r is. Okay, now when you substitute that properly, you're going to have what is on your right hand side, which is 12 combination r x raised to the power 12 minus 2r in bracket minus 1 over 2r. Now, to get the term that have s squared, we set x raised to the power 12 minus 2r equal to x squared. Then 12 minus 2r will be equal to 2. Since this is by using indices, since the base x is on the left hand side and x is on the right hand side, so the powers must be the same. And when you do that, r will now be 5. That is, r plus 1 will now be the sixth term. R will be 5, which is the sixth term. Thus, the term in s squared is, will give us, in summary, minus 99s squared over 4. So that is the term that have s squared in the binomial expansion. Thank you for watching.